This video is to review the topics from Unit 11 circles for tomorrow's test. So the first section is matching. We want to choose the best answer given circle H. So if we have circle H to the right, RT with the lines mean that it's a line that goes on forever in both directions. RT is only intersecting the circle in one spot, so that is going to be a tangent line, which is J. ERA, so arc, ERA, we have to follow it in letter order. That's bigger than a half a circle, so that is going to be a major arc. R is a point. This is where the tangent line is intersecting the circle. So that would be our point of tangency. EA is a segment. So it's starting at E and it's ending at A. It has 2 points on the circle, so that's going to be a chord. That is different than number 8. So in number 8, EA is a line that goes on forever, so it's touching the circle in 2 spots, it's intersecting, so that would be a secant. Make sure you know the difference between 4 and 8. Okay, let's go back up to number 5. HA goes from the center of the circle to a point on the circle, so that is going to be our radius, G. Arc AR is 2 letters, it's a minor arc. Point H is in the center of the circle, so that is our center. RE goes from one side of the circle to the other, and it also goes through the center, so that is a diameter. And then our last part is EAR. So EAR is an arc that goes this way. It's half a circle, so that would be a semicircle. Number 11, solve for x. So we know that x is a radius here, which means this part's also going to be x. We also know that if this is a point of tangency, there is a right angle at the intersection. So we know that this whole side is x plus 6. So when we set up, we have x plus 6 squared is equal to x squared plus 12 squared. So remember, x plus 6 squared is not x squared plus 36. We have to multiply x plus 6 times x plus 6. So we get x squared plus 6x plus 6x plus 36 is equal to x squared plus 144. There's an x squared on both sides, so they cancel out, and we are left with 12x plus 36 is equal to 144. We can subtract 36 from both sides. 12x is equal to 108. And we divide by 12, we get that x equals 9. In number 12, we have a quadrilateral, a 4-sided figure that is inside a circle. The opposite angles have to be supplementary. So to solve for x, we would have 4x plus 20 plus 100 is equal to 180. Remember that they are not congruent. So we get 4x plus 120 is equal to 180. 4x equals 60. So x is 15. Then to solve for y, those are also supplementary. So 7y minus 2 plus 82 is equal to 180. So we get 7y plus 80 is equal to 180. We can subtract 80 from both sides. 7y is equal to 100. So when we divide, this is going to be a fraction of 100 over 7. In number 13, given circle E, arc BC is 4x plus 7, arc AB is 7x minus 3, and arc CD is 2x plus 24. So first thing we want to do is solve for x. We know that from A to B to C that we have a semicircle because AC is a diameter since it's going through the center of the circle and it's a straight line. So we have 7x minus 3 plus 4x plus 7 is equal to 180 degrees because that's how many are in a semicircle. So we get 11x plus 4 is equal to 180. We can subtract 4 from both sides, so 11x equals 176, and we divide x is 16. Once we know x is 16, to get AD, we can substitute into CD. So 2 times 16 plus 24 is 56 degrees. and we can subtract from 180 to get our other arc. So 180 minus 56 gets us 124. If we want the angle AED, that's going to be the same as the arc that it's intercepting, because this is the arc that it's intercepting. So it would also be 124 degrees. Number 14, to find the angle, this is a central angle. So just like the problem we just talked about, this angle is going to be equal to the arc. So that's going to be 97 degrees. In 15, x is not at the center of the circle, so we have to add the arcs and divide by 2. So x is equal to 1/2 of 47 plus 170. So we add those together and divide by 2. We get x equals 108.5 degrees. In 16, when you have the angle outside the circle, you are subtracting. This time we know the angle. So 20 is equal to 1/2 the arc that's further away, 192 minus x. To get rid of the half, we can multiply by 2 on both sides. So the half and the 2 cancel out. We get 40 equals 192 minus x. We can subtract 192 from both sides. So negative 152 equals negative x. So we get x is 152 degrees. In 19, to solve for x, because 53 is an inscribed angle, we would double it. So 53 times 2 to get 106. Then in our circle, we know that one arc is 106 and one arc is 100. So we can subtract from 360 to get the last arc is 154 degrees. Again, y is an inscribed angle, so we would take half of that arc. So y is 77 degrees. In number 20, we have two of the arcs that we can subtract from 360. So we can do 360 minus 57 minus 203, and we get 100 degrees. X is an inscribed angle, so it's half the arc. So that would mean it is 50 degrees. In number 21, we want to solve for x and y. So x is on the outside, so we're going to do x equals 1/2 of 170 minus 84. And we get 43 degrees. And then for y, we have 1/2 of 170 plus 84. And that gets us 127 degrees. In number 22, these chords are marked congruent, which means these arcs are also congruent. So they're both 104 degrees. So we can subtract from 360, and we get that this arc is 152. X is a central angle, so it's going to be the same as the arc 152, whereas y is only going to be half because it's an inscribed angle. So when we cut that in half, divide by 2, we get 76 degrees. Number 23, there are two tangent lines. So the tangent lines are congruent to each other. So we have 4x plus 10 is equal to 6x minus 18. We get 2x equals 28. So x is 14. In 24, we have a chord problem. So the pieces of each chord get multiplied together. So 6 times 10 is equal to 12x. 60 equals 12x. So x is 5. In number 25, this is a tangent secant. So the tangent segment is going to be squared. 25 squared equals, we want the outside, 5, times the whole segment. Well, in this case, it would be 5 plus x or x plus 5, either way. So we get 625 is equal to 25 plus 5x. We can subtract 25 from both sides, so 600 is equal to 5x. When we divide, we get x is 120. In 26, this is a secant problem. So we want to use the outside times the whole segment. So in this case, it would be 10 plus x, or we could say x plus 10. And then we have the outside 3 times the whole length of 8. So we have x times x plus 10 is equal to 3 times 8. X squared plus 10x is equal to 24. X squared minus 10x minus 24 equals 0. So we need two numbers that multiply to negative 24 and add to 10. We have x plus 12 and x minus 2 equals 0. So x equals negative 12 and x equals 2. Negative 12 is not possible because we can't have a negative side length. Number 27. The area of the circle is 16 pi feet squared. What is the diameter? So first we need to figure out what our radius is. So we know the area is equal to pi r squared. So 16 pi is equal to pi r squared. We can divide by pi on both sides. So 16 equals r squared, which means r is 4. So if our radius is 4, the diameter is going to equal 2 times 4, which in this case would be 8 feet. Number 28, given circle A, find the following. So we want the measure of arc A of BC. So it's missing the letters here. We'll just add them, A, B, C. So our arc is going to have the same as the angle measure. So if the angle measure is 150 degrees, the arc is also 150 degrees for the measure. For the arc length, it's part of the circumference. So we want to do circumference 2 pi r, which our radius is 24, times the measure of 150 over 360. So in your calculator, you can multiply everything except the pi, and we get 20 pi. So after you put in your calculator, remember to put pi with your answer. For the area of the sector, we're going to do the area of the circle, so pi 24 squared times the measure over 360, because we only want part of the circle. So again, put in your calculator without the pi, 24 squared times 150 divided by 360 gets us 240 pi feet squared. Remember that area is always squared units. Number 29, a circle is 8 centimeters away from the center of the circle. If the radius has a length of 10 centimeters, what is the length of the chord? So when we draw our circle, we have a chord, we have a radius going through it. So it's perpendicular and bisects that chord. We know that it's 8 away from the center, and we know that the radius is 10. So we can do Pythagorean theorem. 10 squared equals 8 squared plus x squared. 100 equals 64 plus x squared. 36 equals x squared. So x is 6. So each part of the chord is 6 and 6. So our whole chord length is going to be 12 centimeters.